Hello friends, in this video I am going to explain Ohm's law in detail. And resistance of an unknown resistor can be found by the voltage versus current graph. Then we will discuss what are the factors on which resistance depends, and finally resistivity. First, let us see what is Ohm's law. At a constant temperature, the current flowing through the conductor is directly proportional to the potential difference across the two ends of the conductor. Okay, so according to the statement, we can write mathematically as current is directly proportional to potential difference, that is V. In order to remove this proportionality sign, okay, we have to introduce a constant, and that constant is G, right? What is G? G is reciprocal of resistance. Fine. So we can write I is equal to V by R. This is Ohm's law. Now let us see this magic triangle. So in this magic triangle, what is V? V is equal to I into R. Okay. And we can represent, or else we can find the current I, how V divided by R. So we have a division symbol here. Okay, I can be found by V by R. And how to find R? So we can find R is equal to V divided by I. Okay. So from this magic triangle, we are able to find the relationship of voltage, current, and resistance. Fine. So now let us see the circuit to verify Ohm's law. In this circuit, we can find that there is a rheostat here. Can you find the rheostat? This is the rheostat. What is this rheostat used for? Why do we use this? See, as per the definition of Ohm's law, this is the voltage applied. So because of this voltage, current is flowing through the circuit. Okay, so what is that we need to do in this circuit is that we have resistance R. So this R resistance can be electric bulb, okay, or it can be unknown resistor. Fine. So we need to find out the value of this unknown resistor. How we are going to find? For that we need voltmeter to measure the voltage across this resistor, and current. To measure the current, we have here ammeter. Okay, ammeter is used to measure the current. Fine. And this rheostat, why do we have? What is the purpose of this rheostat? This rheostat used to vary the resistance. It will vary the resistance. Can you see a pointer here? So it will be varying. So you can find here that it can be kept in the minimum position to maximum position. We can adjust the value of the resistance. So we know that when we increase the resistance, what is going to happen? We know the relation between current and resistance. So when the resistance is going to increase, current is going to decrease. Okay, and vice versa. If we are going to decrease the resistance, then the current is going to increase. So we have a control over the current by using this rheostat. Okay, fine. And the purpose of this rheostat is to vary the resistance in the circuit. Okay, that means the current is also varied, the resistance is also varied here. So for the different values of voltage and current, we need to take different readings. Okay, by adjusting this rheostat right from the minimum to maximum position, we need to take out different sets of readings, say 5 sets of readings. We need to note down what is the voltage and what is current. Okay, like that we need to, next step what we need to do, we need to adjust the rheostat to the next level, that is to the next turn, and we need to find out what is the voltage and current. Fine. So we have to tabulate the value of voltage and current like this for n number of readings, and then we need to find out resistance value. So how can we find resistance? Resistance can be found, okay, by the ratio V by I. Okay, what actually is resistance? Resistance is the property which will oppose the flow of current. Okay, so that definition I will explain it to you. So now here I am going to discuss one more important concept here. Always the voltmeter should be connected in parallel. Okay, so this will measure the voltage. In order to measure the voltage, we have to keep across the two terminals. Okay, and why should not the voltmeter be connected in series? Why? Because this voltmeter has high resistance. Okay, so if I connect this voltmeter instead of this ammeter, if I connect here voltmeter, okay, instead of this, if I connect here voltmeter, what will happen? This resistance is going to be more. Voltmeter resistance is going to be high. It has got high resistance. So therefore, the current flowing through this will be 0 and the voltage drop will be 0. No current will be flowing, and therefore what happened? There will not be any voltage drop. So we will not be able to find. Okay, and the incorrect readings we will be getting. So that is the reason we should not connect the voltmeter in series. Now what I will do is, and you may ask the question, why always the voltmeter be connected in parallel? This is the reason. Okay, and the another question you can arise, that why ammeter should be connected in series, why not in parallel? Okay, so if I connected the ammeter, this is ammeter, if I am going to connect ammeter in parallel, ammeter has got low resistance. Okay, ammeter has got low resistance. Then what will happen to the current? Current will be increasing. So here what happens? All the current flowing, it will go through this path, and less current will be going to this resistor. So all the current will flow through this and it will make short circuit, and the ammeter is going to burn and damage. That's the reason we should not connect ammeter in parallel. We need to connect it in series. Okay, so next, this is another circuit to verify Ohm's law. Okay, here we use a battery eliminator, which I have already discussed in the series 1. Okay, so battery eliminator will give different, by using the knob we can select the different voltages, okay, increase the voltages, and for the different values of the voltages we need to note down what is the value of this voltage across the resistance, unknown resistance. This is the unknown resistance. Okay, and the current through this resistance we need to find. So we are going to tabulate it by increasing the supply voltage. Fine, and this is another way of verifying Ohm's law. Okay, now by making note of all the voltmeter and ammeter reading, we can tabulate it like this. Suppose if we are getting this set of readings, how to draw the graph, I will tell you. Here in this particular set of readings, when we consider, we are going to take a graph sheet, and on the x-axis we are going to take current, and on y-axis we are going to take voltage. Why we are taking current on x-axis and voltage on y-axis? We can also take voltage on x-axis and current on y-axis. Why we are not doing so? I will tell you one reason. That is because First, let us plot all these values. I will let you know why we have taken current on the x-axis and voltage on the y-axis. Because we need to find out the unknown resistance, right? Fine, I will tell you. So here, what is the first reading? See the difference of these two readings. It is 0.1. See the difference of these two readings. It is 0.2. So either we can take in steps of 0.1 or in steps of 0.2. We can take in x-axis. So here they have taken in steps of 0.1. 0.1, 0.2, 0.3, 0.4, 0.5 like that till 1.0. Okay, every for 1 centimeter we are taking 0.1 amps. So say we have to take the scale. Okay, so x-axis in this I am going to take 1 centimeter is going to be equal to, what is that, 0.1 amps. 0.1 amps. And y-axis we are going to take 1 centimeter we are going to take equal to how much? Here what is the difference? 2.5, and here the difference between these two readings, it is 5. Okay, so I will take 5 in steps of 5. So here 5, 10, 15, 20, 25. So we have 1 centimeter we are going to take 5 volt. We are going to take 5 volt. So this is the scale. On fixing the scale, we are going to number it, and then we are going to plot now. So first reading is 0.1 and 2.5. So 0.1 and 2.5 is over here. So now this is the first plot, the first reading. We have taken the first reading. What about the second reading? It is 0.25. So this is 0.2 and this is 5. So here the second reading. Third reading will be 0.410. 0.410. This is the point. And next 0.6 15. Okay, so this is the point. And then 1 and 25. 1 and 25. So we have plotted the points. Now we have to join all these points. By joining, we find that they are straight line. Can you observe? They are in straight line. So this shows that voltage is directly proportional to current. Whether this is Ohm's law? No. Current is directly proportional to voltage. Okay, but in some of the textbook they would have given voltage is directly proportional to current. But it is better to say current is directly proportional to voltage, because current is dependent on voltage, not voltage dependent on current. Fine. Okay, so we have verified, since we are getting linear straight line, which shows that the linear relationship of voltage and current. So this graph has represented the linear relationship of voltage and current. As the current is increasing, even the voltage is increasing. So they are linear. So we have verified Ohm's law. The next thing, we need to find out the unknown resistance. As I have said, resistance is equal to V by I. Isn't it? How to find this resistance from this graph? Yes, I will let you know now. So in this graph, what we have to do is we need to find out the slope. I think in lower classes you would have studied what is meant by slope in mathematics. Slope is equal to delta y divided by delta x, isn't it? So now let us take any two consecutive reading. Fine. I'm going to take these two readings. Okay, I'm going to plot. I'm going to find out the slope for this two consecutive reading. Now see the difference of these two readings, 0.6 and 0.4. It's going to be taken as delta I, because change in current, no. So this is current and this is voltage. Okay, and this two readings we need to take. So these two readings represent what? Delta V. What is the difference? This is 10 and this is 15. 15 minus 10 is going to be 5. So delta V is going to be 5. And delta I is how much? 0.2. The difference between 0.6 and 0.4 is 0.2, right? So now we have to right. What is that? Slope is equal to now delta y by delta x. What is there in delta y? We have voltage in y-axis. So therefore delta V we write. And what is there in x-axis? We have current. Okay. So therefore I write delta I. So now what will happen? What is the ratio of voltage and current? We call it as resistance, right? So by finding the slope, we are finding out the resistance. Now did you understand why did we take current in the x-axis and voltage in y-axis? This is the reason, in order to find the slope. So in order to find out the resistance, so slope is going to give the value of the resistance. Suppose if I had taken current in y-axis and voltage in x-axis, what I would have found? I would have found, by taking the slope, what I would get G, which is 1 by R. Okay, to find the conductance, we need to take V in the x-axis and I in y-axis. Suppose if you want to find a resistance, then we need to take I in x-axis and V in y-axis. Okay, so this is done. So we have done with verification of Ohm's law, and we have found out what is the value of unknown resistance, right? So now we will discuss what is meant by resistance. Already I said, what is resistance? It is the property of the conductor to resist the flow of current. It is just like a friction in mechanical terms. You know what is friction? When you take a toy car and you just move it over the rough surface. So when the surface is rougher, what will happen? The car will not be able to move through a long distance. Okay, speed of the car is going to become less. That means current is less. Okay, in electrical terms we say current is less. So I will consider car. Okay, I will consider car. So the surface is rough. If it is going to be rough surface, the car will not move. So this rough surface represents the friction. So we call it as friction. What is friction? You know, in the mechanical terms. So when there is friction, the car will not move. The speed is going to get reduced. Suppose if the friction is less, when the friction is less, suppose if we have a smooth surface, then the toy car will move for a long distance. The speed will be more, current will be more. Okay, so in that way, I think you understood what is resistance. Okay, in the mechanical terms also I have explained. As I said, what is the car represents? Car represents the current. Okay, what does the friction represent? Resistance. Fine. Okay, so we know that by Ohm's law, R is equal to V by I. What is the unit of voltage? Volts. What is the unit of current? Amps. Okay, and what is the unit of resistance? It is volt per ampere. Volt per ampere is equivalent to ohms. It is named after the scientist. Okay, and the Greek letter, this is the Greek letter which we use to represent ohm. Okay, what are the larger units of resistance? Kilo ohm and mega ohm. Mega means 10 to the power 6 and kilo means 10 to the power 3. Okay, so hope you understood all these concepts. Now we will move on to what are the factors on which resistance depends. Okay, so let us see one by one. Resistance is directly proportional to length, right? Suppose if the length is increasing, then what will happen? When the length is increasing, resistance is increasing. Okay, now if I reduce the length, what happens? When the length is decreasing, resistance will also decrease. Okay, so they are directly proportional. Next, resistance depends on the area of cross section, right? What is this area of cross section? See here, I will explain to you now. This is called, suppose if this is the conductor, right? And this is the area of cross section. So when the area of cross section is increasing, what happens to resistance? You find that large space we are getting. No, when the area is increasing, area of cross section increasing, we get a large area. So the current will be more. The current more means resistance will be less. Yes, so resistance will be less. So it is inversely proportional, we say. And suppose if the area is going to decrease, what happens? So I'm going to take, this is the area. This area we are going to, area of cross section we are going to decrease. By decreasing the area of cross section, what happens to resistance? Resistance is going to increase. So they are inversely proportional. I think you can see here, if area is decreasing, resistance is going to increase. So they are inversely proportional. By combining this equation and this equation, we will get R is equal to, R is proportional to L by A. Now in order to remove this proportionality sign, we have to introduce a constant. Okay, and that constant is called rho. What is this rho, ma? It is called resistivity. Okay, rho is called resistivity. I told you, no, the other term which we have to discuss, resistivity. Rho is resistivity. It is also a constant. Just like resistance, this is also a constant. And I will give the definition of what is this resistivity. Okay, before going for this definition, let us rearrange this term and find what will be the SI unit of this resistivity. Shall I take this equation and by rearranging, how will you find this resistivity? Resistivity is equal to RA divided by L, isn't it? So now what is the unit for area? Area is meter cube. What about the length? Length is in meter. What about the resistance? Resistance is ohm. Okay, now meter get cancelled, you get a ohm meter. So the SI unit of resistivity is ohm meter. Did you understand what is the SI unit of resistivity? Ohm meter. Now I will explain you what is meant by resistivity. Okay, so what is resistivity? Let me take, suppose you consider that this is a small part of a conductor. I will consider it as a cube. Okay, so here if I take one, the length is going to be 1 meter, and what will be the area of a cube? It will be length into length, isn't it? So meter square. So now what I will do is R is equal to, we know that it is R, rho is equal to RA by L, isn't it? R is equal to rho L by A and rho is equal to RA by L. Now if I take area is equal to 1 meter square and what is the length? Length is equal to 1 meter. If I take like this, okay, and if I substitute, what will I get? Rho here, this is also 1, this is also 1. Both are 1. So therefore I will get rho is equal to R. That means specific resistance. The other name of resistivity is specific resistance. I told what is rho. Rho is resistivity, isn't it? Why do we call that as specific resistance? See, we are having specifically here what we have taken, meter cube of a material we have taken, a cube. Okay, meter cube of a cube having once area 1 centimeter, 1 meter square and the length 1 meter. If we take such kind of material, then we will find that resistivity is equal to resistance. And how do we define this resistivity? The other name for this, I told that it is specific resistance. The other name is specific resistance. So the resistance that is offered between the opposite faces of a meter cube of a material, this resistance we call it a specific resistance. Understood? Right. So now we will go solving the problems. Fine. So let us move to the problem. Yeah. In this problem, what have they given and what is given and what to find, we need to know first. For any problem given, we need to write the given data and then what to find and what will be the solution, which is relating the expressions or the given parameters and unknowns. So here a wire of a given material having the length L. So here, 1 minute, here we have here length L, okay, and area of cross section is A. And what about resistance? Resistance is 4 ohm. So let me take and another resistance of another wire. We are taking another wire having the same material only, length is L by 2, area is 2A. So first wire, okay, the first wire is having the length L and area A. The second wire is having the length L by 2. We are having the length, what is it, L by 2. So instead I will take, find here. So L by 2 means half of this, right? So it is L by 2. And what about the area? Area is increased, doubled, okay, like this. So this is the area for this first one. This is the area. And here the area is doubled, 2A. And now we need to find the resistivity for this and resistance for this and this. So what will be this resistance? I will take it as R1, and this resistance, the second material, I will take it as resistance R2. So how to find R1? R1 is equal to rho L by A, we know. So here L and A we have. So you substitute that R1 is equal to rho L by A. So what is the value of resistance given here? 4. So we are writing that. And what about the second wire? We have the length is L by 2 and the area is going to be 2A. Okay, so when we write, what is that, 1 by 2 divided by 2, it's going to be 1 by 4, isn't it? So here 1 by 4 we have, and remaining we have here rho L by A. So we are writing rho L by A. What is rho L by A? Rho L by A is R1. So we are writing R1 here. And what is the value of this R1? It is 4 ohm, right? So when we substitute this 4, what we will get? 1 by 4 into 4. So get cancelled and we will get 1 ohm. So the resistance of the second material is going to be 1 ohm. So what is the resistance of the new wire? It is 1 ohm. We have found the resistance of the second wire. That is what asked in the question. Find the resistance of another wire. Suppose if they ask by what times the second wire is with respect to first wire. So that is, till here you need to write. That is, you need to say that the second resistance is 1 by 4 times of the original resistance. That is the first resistance. So this relation we have already found, but they have asked to find the resistance of the another wire. So therefore we need to find the value of the second resistance. Okay, fine. I think you have understood the concepts of what is Ohm's law and how to find the unknown resistance, and we have seen what is resistance and what is resistivity in detail and problems on resistivity. Hope you understood all the concept. If you like, please subscribe button. Please press the subscribe button and like the video. Fine. Thank you.